Hello everyone, this is Manikyala Rao, working as assistant professor in the Department of AI and ML in BVRIT, Narsapur. Now today I want to discuss about how to read and write the data into the external files. Just like our external files means we will take some other file, just like .csv files or .xml files like that. So I will show you one by one. So now coming to the first one, using CSV files, how to read and write the data from the external files. So now here the main steps are to create and read and write the content into the file is, first step is we have to create the file. So for that what we have to take means, first creating the file means file dot create of file.csv. That means it is used to create the file named as file.csv. So after creating the file, so they need to insert the content into the file. For that I taken the variable name, so that is data. So that data contains the three attributes, that is name. So I want to store the names, that is John, Alice and Bob in one row and one column, and next column age, so that contains different ages, and next one is countries, so different countries. So I want to store the data in the form of CSV file. CSV means comma separatable values. So that values we need to store in the new file. So that file named as file.csv. So in the file.csv I will take the attributes as name, age and the country. So after writing the data, I want to write the data. So write.csv is used to write the data into the files. So I want to write the content, so that is data into file.csv file. So this name, age and the country, all the attributes are to be stored in the file.csv file. So now I want to retrieve the data from the file.csv. So for that what I have to read is, so data, so that our variable name tends to read.csv. So read.csv is used to read, that means they need to retrieve the data from the CSV files. So read.csv of file.csv. So they need to retrieve the data values of name, age and country from the given .csv file. So that is about how to read and write the data from the CSV files. So this is about the CSV files, and coming to the next one, XML files. Starting XML means extensible markup language, that is used to access and display the data in the form of user defined tags. Just like user defined tags means, for example, if you have to take the textbook. So for example, I will take the textbook. So in the textbook, what I have to write, so the textbook contains the name and the textbook contains page numbers. So we want to write the names, the particular tag names are the particular user defined names. The user has to give their own names for this one, that is called as XML, extensible markup language. So they need to accept the user defined tags in the given structure. So the structure for XML is root node, child node, close the child node, close the root node. So root node means the main starting root element. So inside the child node, so inside that another child node is there, means we have to write the structure like that. So this is the main structure for the XML. Okay. So now I will take the root node as, for example, the root node as book. Inside that I will take the book 1. Here I will take the root node as books, and inside that I will take the child node as book 1. So I want to close the book 1, and next I want to close the books. So in case if the given structure is having more number of books, so we have to take in the books to root node, we have to take book 1, and inside that we have to write the content and close the book 1, and next we will take book 2, and inside that we will write the content and close the book 2. So like that we have to create the XML structure for this one. So that is about XML structure. So now if we have to access the XML files into the R programming, so for that what we have to use is install.packages. So what packages we need to execute the XML files and to read and execute, to write the content into the XML files, we will use the packages as XML2, that is a version 2 is the version name for XML. So they need to retrieve the data, they need to retrieve the root node of the XML, child node of the XML, subchild node of the XML, all the values of the XML, all the contents are to be retrieved by using the XML contents. So now we have to see So if I have to retrieve the total XML file, whatever we are written the structure, the same structure we need to retrieve means we have to write the exact content as variable name XML underscore data. So that is our variable name. So read underscore XML of your file name. So that is used to retrieve your total XML file. Whatever the user is given the XML file, the total content as is output will be displayed. So for that we will use the method as read underscore XML. So we are calling print of XML data means, so they need to print the XML document. That means the root node, child node, subchild node, like that the values will be retrieved in the given XML format. Whatever the user is written, the same XML content will be retrieved from the given structure. So now, so for example, if I have to display the contents, like first I want to display the root node, and next I want to display the child node, and next child node values, subchild nodes, like that if I want to display the contents means see the structure. So first I created a structure of the XML file, so that is file.create of our XML file name. So inside that XML file name, so I want to read the content. So read.xml of. So I taken the structures as the root node is products, child node is product, and inside that I taken the two attributes in the child node. So that is name and the price. So like this we take in the XML file. So now I want to write that content into the XML. So we have to use the method as write underscore XML. So write underscore XML is used to write the content into our XML file, and after that if I have to retrieve the data means, so the root node is equal to XML underscore root of node. So that means they need to retrieve the node node. Next child node means the particular XML name of child node. So like that they need to retrieve the data from this. So XML underscore root of data. So they need to retrieve the root node for the element. So we are calling XML underscore name of root node means, so they need to retrieve the node of the population. So root node is what? So they need to display the products. That is our root node. So next child name is what? Product. And inside the child name values are name and price. So these two are the subchild elements values. So here we are calling XML name of root node means they need to retrieve the product. Next, so we have to take the child node. So say child of particular root node. So that means they need to retrieve the child node for the given thing. So child node is what? Product. Next, so XML underscore text of child node. So that means in the child node, whatever the elements have to be exist, so that values is retrieved. So in that what happens? Name and next price. So those name and price values will be retrieved like this. So that is about to read and write the data from the XML file. So this is about how to read and write the data into our XML file, and based on the root node we need to retrieve, child node we have to retrieve, and by the XML underscore text, XML underscore root is used to retrieve the root node, XML underscore children is used to retrieve the child node values, just like here product is our child node. Next XML underscore text of the child node means in the child node whatever values are available here, we are having the child node as product. So in that product what if the values are there? Name and laptop. So what is the name of the particular product is there, and what is the price for the given product? Those two values will be retrieved by using XML underscore text of child node. So that is about to retrieve the data from the XML file. Next, coming to the next one, how to retrieve the data from the web. So that means we are given the list of packages. For example, if I have to see the site as CRAN, that means compressive archive or archive network. So it is contains the elements and the libraries of the packages are available in the network that is belongs to R. So actually we are using the version as R 4.4.2 version to execute the R programming. So now here what we have to do is, so we have to collect the data from the web with the help of, so first the thing is install packages of RWest. So RWest is used to retrieve R related all the packages and all the internet sources that is to be there in the CRAN site. So those all the contents will be displayed from the given site. So next, so after that the steps is used to access the data. So first thing field we have to take as URL. So that means uniform resource locator. So that means the site, from which site we have to collect the data. So I want to collect the data from the cran.or-project.org. So from this site I want to retrieve the data as packages by names. So from this site we need to collect the packages from the order one by one. So now for that, what I have to take is package names. First one is URL. So first from that site, what I have to read underscore HTML means they need to retrieve HTML content, and next percentile greater than percentile means they need to include into the given site. Next I want to read HTML nodes, HTML text, and comma sequence of 1 comma length dot by is equal to 2. So that means in sequential wise, that means in order wise, length dot means 1 by 1, by is equal to 2 means they need to retrieve first package name, and next 1 plus 2, 3. So third package name, and next 3 plus 2, 5. Fifth package name, next 5 plus 2, 7. Seventh package name. Like that, the packages will be displayed in the order. So that is the package names, that is from 1 to 5. So 1, 3, 5, 7, 9. Why? Because I taken the structure sequence of 1 comma length by equal to 2. So that is used to add 1 by 1. First index is 1. Next index by 2 means 1 plus 2, 3. Next 3 plus 2, 5. Next 5 plus 2, 7. Like that, the values will be taken and they retrieve the values, package names like this. So this is the output for this one. So like this, 5 package names will be displayed in this from the site. Next one, json files. So json file means JavaScript object notation files. So from the JavaScript, so that is just like JavaScript is used to create the dynamic web pages and access the content dynamically from the given sites, and we need to change the content in the static pages, and by given JavaScript we need to modify the existing internal HTML contents, and that should be displayed the static web page into dynamic web pages. For that we are using JSON. So here I am using the JSON file. So for that I want to install the package. If you have to access the files from the R programming into the given XML, so that is for that we are using the content as install.packages of JSONLite. So that JSONLite is the package name that is used to access the JSON files into our R programming tool. So after taking that one, so I want to take the JSON data, second one. So inside that I want to take the contents are name, age and cities. 3 attributes I taken here. So I want to add the JSON content into our file, and after reading the content from the file, so now I want to write off JSON data comma data.json. So I want to add the content of previous name, age and city into our data.json file. So after writing, so I want to retrieve that means read underscore JSON of the particular JSON file name. So whatever the content we have to be added previously in the name John, Alice, Bob, 30, 25, party ages, New York, Los Angeles and Chicago, these 3 values will be retrieved from the JSON file, and that is to be stored in our particular location. Whatever the location we have to be given, in that location the JSON files will be stored. And from the JSON file, by using read underscore JSON, we need to retrieve the data from the JSON files, and whatever we have to be stored in the particular JSON file, that JSON file content will be retrieved like this based on the index, serial number of indexes. So next one. So now the next one, if I have to read and store the data in the form of database files. So actually we are using the database is RSQL, so R programming SQL. So for that, the first step is we have to install the package. So that package name is install.packages of RSQLite. So RSQLite means R programming SQLite means it is used to access all the SQL queries in the form of R programming to run. The data is to be there in the table database, and what are the values we have to be inserted and what are the values we have to be updated, and if I want to delete the table from the structure, if I want to drop the table from this one, like this, these all the commands will be displayed from this. So now we have to see first one. The first step is first we have to establish the connection. So for that what I have to take means db connect of the particular package name colon that package my database.db. So this my database.db is used to create the new database, that is my database.db. So by using this my database only, we are using the database to create the table, to insert the content, to display the content from the given table. So This is our package name RSQLite. Inside that we are using SQL is our database name, comma. So this is our database, my database.db. So next, after taking that one, so we are adding some content, data.frame of these values, ID, name and the ages for this one. So after that, db write table of connection, comma, my table, comma, data. So my table is our table name. The table is created, and so inside the table the data is to be inserted with the fields are ID, name, ages. These three columns are to be inserted into our database. The table name is my table. So next, I want to insert the data. So for that, what I have to take is new data is equal to data.frame. So I want to actually, the table is already having in previous, in the table is already having three fields, three rows. Now I want to add two more rows inside the table. So now I want to do what is db write table of my table, comma, new data, comma, append is equal to true. So append is equal to true means it is used to add more than one row in our existing table. So whatever we want to add, that is to be stored in the new data, and that new data, the two rows will be added into our database. So now finally our database is having 1, 2, 3, 4, 5, total 5 IDs are there, 5 names are there, along with 5 ages are there. So total 5 contents will be stored in our database. Now retrieving data means, so we have to use the read table. Read table is used to retrieve the data from the file. Write table is used to adding the content into the database file. So read table of particular connection, comma, particular my table. So they need to retrieve the content. So total 5 IDs, names and ages. Next, I want to update the data into the table. So for that, what I have to update? So that means, for example, if I want to update the particular constraint value with some name. So I taken this update in my table, set a is equal to 45, where name is equal to Bob. So what happens here? At the age 45, we need to change name is equal to Bob. In the place of name is equal to Bob, we need to update the age with 45. So now we will see the previous one. I want to change the Bob age is 45. So finally that value is updated into our table. So that Bob age is actually 40. Now I want to change that age value 45. So in the place of name equal to Bob, we need to replace the age value with 40 to 45. So that is updation. Next one, after that we are executing the query. So by using that one, db execute connection, comma, query. So the query is executed, and finally the table will be updated from the structure. Next, the updated data is this. If I want to delete means delete from table name where name is equal to Mike. So that means whenever the name value is Mike is there, that name Mike is total row will be deleted from the structure. So that is about how to insert the contents, how to update the content, how to delete the content from the given database files, and finally we are using the database as SQL or SQL. So our programming structured query language. So that is about database. Next one, Excel files. If I have to read the XSL files. So XSL files means same. For that we are using the package names are XLSX, read Excel, write Excel. So that is used to read the content from the XML files, write the content into our XML files, write Excel is used. Now after installing the packages, so we have to read the content. So I given some location. So EDA examples exam.xl. So I already created some Excel file. So from that XML file, I want to read the data and I want to print the data from the file. So inside that file, whatever the content is available. So for that, I taken, so write.xls of this content into the file. First, I write in the content into the file, and next, whatever the content I taken, so that values will be printed in the form of XSL file. So that is about reading XSL. So these are the contents are used to reading the data and writing the data into the file with the different formats. Now coming to the next one. So working with charts and graphs. That means, for example, if I want whatever the contents or data points were to be taken, the data points we need to show in the form of graphical structure. That means the data will be visualized in the form of graphs, and that from graphs will be with a different formats. So coming to the first one, histogram. So histogram is a collection of distribution of set of points, and the set of points is to be represented in the form of two axes. First one is x-axis and second one is y-axis. So in the x-axis, for the first points we have to be taken frequency, means after calculation of the frequency means how many times that particular values will be occurred in the given data set. We need to identify and we have to show the form histogram like this. So for this we are having different steps to implement histogram. So now here we are taken, there are mainly three steps are there. First step is we need to take some range of data and split that range of data into equal bins, and we have to calculate the bin width is maximum minus minimum value by k. So maximum value means the highest value in your data set, minimum value means the lowest value in your data set, k means how many size of number, that means how many rows are exist in your database. For a particular data set, whatever the rows are available, that count is k. So next frequency means that condition, from what condition to what condition we are taking, the starting position what and the ending position value what. After calculating, so we are calculating density to draw the histogram for the given value. So now we will take the scores. So these are the data sets. So 12, 18, 25, 30. So now first I will calculate the first one, range into two equal sizes. So actually 4 is there. We are dividing that one into 2. So next we will calculate the minimum score value is 12 and the maximum score is 30. So finally we are calculating the bin sizes are, range is 30 minus 12, 18. So bin value range by number of bits. So ranges are, so total 18 we are calculated divided by the number of bins. We are dividing this one into two equal parts. So for 12, 18 one part, 25, 30 one part. So that's why, so 18 by 2, so that is 9. So how to prepare the bins? So actually from starting onwards, we will distribute that one into 9 bins. So that's why I taken 12 to 20, 21 to 30. So 12 to 20, so total 9 bins are there. Here total 9 bins and here total 9 bins. Equally we are distributed based on our bin size. So that is about calculating bin. Next, second step, calculate the frequency of the bin. So frequency of bin means first condition. So greater than or equal to 12 and less than 20. So how many values are there? Greater than 12 and less than 50. So 12 and 18. So 12 and 18 will be there. Next 25 and 30. So this condition greater than or equal to 1 and less than 30. So that is scores 25 and 30. So frequencies are what? For the first bin we are having two frequencies. For the second bin also we are having two frequencies. First condition, they satisfy two values are there in the data set, that is 12 and 18. And the second condition, two values are there in the data set, that is 25 and 30. So we are sharing equally the frequencies for the bins. So based on that, after calculating that one, so density we are calculating. So frequency means 2 divided by 4 values are there into bin width is 9. So after calculating bin 1, bin 2 density, those two values are same and the frequencies are same. So that means our program is true. But because whenever we are taking the values, that frequency will be same and the density will be same based on that values. So our values will be executed properly and the histogram will be like this. So see, the x-axis contains the bin values and the y-axis contains the frequency. So we are calculated for bin 1 and bin 2, that frequencies are 2 and 2. So that's why we are dividing into 2. So the final frequency value is 2 and the bin value is also 2. So that is about the histographical representation of data. Next one, box plot. So if I want to retrieve the data in the form of box, just like this. If I want to retrieve the data in the form of box, so for that we have to calculate the box plot with these steps. So first one, we need to arrange the data in the sorting order. So that means whatever the data set values they are given, we have to arrange those values in the sorting order. Second one, we will calculate the minimum and maximum values for the given set. And next one, we have to calculate the mean for the Q1, mean for Q2 and mean for Q3. So Q1 means the lower half of the data, Q2 means middle half of the data and the Q3 means upper half of the data. So IQR means this Q3 minus Q1. That means upper half minus lower half is IQR. And finally, we will consider that particular value is belongs to outliers of the section or inlayers of the section. So outliers means that is out of the loop from the given structure. In case if you are given inlayers means within that structure values only, the values will be exist and the maximum minimum values will be there. So now here see, I have taken one example that contains the values 12, 18, 25, 30 and 40. So it is a 5-number summary. So first step is what? We need to identify the maximum value and minimum value. So first minimum value is 12, maximum value is 40. So minimum is 12 and maximum value is 40. So next step is we have to identify the Q1 value. Q1 means that is the lower half of the given value. So lower half value is 12 and 18. So median of 12, 18 means 12 plus 18 by 2. So 30 by 2, 15. Next Q2 means median of the middle values. So all the values in the set. So that is 25. Next upper half of the data. So that means the maximum values in the data set 25, 30, 40. So that is 25 plus 30 plus 40 divided by 2. So that divided by 3. So that is 30. So next we are calculating IQR, interquartile range. So after calculating that one, so if we are calculating, so 52 point greater than 52.5 and less than 7 minus 7.5. So in between that range, the mean Q1, Q3 and median value 21.5 will be there. So that's why they are having no outliers in the data set. So no outliers means within that particular structure, whatever the values we have to be taken, those values will be satisfied the condition with the values as minimum and maximum. In between minimum and maximum only the Q1, median, Q3 values will be exist. So that is called the box plot in the given structure. Next one, bar charts. So in the form of bar charts, we have to represent the graph with the different values, means we are having these steps. First one is determine the categories. Next, after that, calculate the frequencies for the given data set. And next one, determine the scale and draw the graph for this one. So how to collect the data from the given chart. So I will take one example. So I am taking the example as the colors, different colors with the frequencies for this one. So that the frequencies I defined as individual number of statements, and after taking, so the maximum frequency for this one is 7, that is blue color, highest frequency is there. And next one, the scale between these two is frequency starting from 0 up to 10 values are there. So that is nearest to 10. So that is general values taken, and after taking that one, and next we are calculating. So out of 5, total 7 is there. So out of 5 by 7 into 10. So maximum value is 7. So that's why 5 by 7 into 10, 7.14. So based on the our values, so red value is 5 and the next value is 7 and next two values are 4, 4. Based on that, we have to draw the graph in the form of bar charts. This is about the bar chart. Next one, line graphs. So line graphs means we are taking some serial of points, the continuous points we are taking, and based on that continuous points, we need to draw the line in between the points. And for that, we are collecting the data and taking the scale for the x-axis what values we will take, and for y-axis what values we will take, and after that plot the points and draw the lines between the graph. So now we will see how to draw the lines. So how to take the points for this one. So I will take one example for this one. So these are the quartiles, Q1, Q2, Q3, Q4. So 4 quarters are there. That means 4 parts are there. That 4 points is used to draw the line in between the graph. So the sales 100, first Q1 100, next 120, next 150, next 180 is there. So I will take the sizes from 0 to 200, the scale size. So it is starting from 0 up to 200 only, the values will be there. So based on that values, I am representing the first value, second value, third and fourth values. So after taking those 4 values, I want to draw the graph. So like this. So 100, 120, 150 and 180. So like this, the values will be drawn. The graph format. So that is about line graphs. Next one, scatter the plot. So scatter the plot means in between that one points, we are taking the relationship between the continuous variables. So continuous variables means just like the categorical variables, continuous variables in between the 2 points or 2 variable values, we have to connect the line, and in between y-axis and x-axis we will show the plots for this one. So I will show you this one. So first I have taken x value and y value. So x values are 2, 4, 6, 8, 10 and y values are 4, 6, 8, 10, 12. So in the scatter plot means they will compare the x value with y value. So x value is 2, y value is 4. So at the point, the x-axis 2 and the y-axis 4, this means this one. X-axis 2, y-axis 4, that point will be scattered. Scatter plot means x and y-axis point just like pair of values 2, 4, 4, 6, 6, 8, 8, 10, 10, 12. All points will be point out. That is about scatter plot. So this is about the data visualizations in R. So thank you for this one. So these are the different concepts. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.